Cold morning this morning. We're just delivering 10 air source heat pumps to a site. It's a leisure centre. The heat pumps have been used for decarbonising the heating. They're changing all of the radiators, new air handling units going in with low temperature coils. These heat pumps will be running with 45, 40 flow and return temperatures, so to give optimum efficiency. They work with weather compensation, so lowering the flow temperature when the ambient's higher. The 10 heat pumps are 78 kilowatts each, so we're giving a total of 780 kilowatts. As well as the space heating heat pumps, we're going to have a 150 kilowatt CO2 heat pump, which will be heating the domestic hot water for all the showers. We're using a CO2 heat pump for domestic hot water because CO2 heat pumps are extremely efficient when heating water to a high temperature. The CO2 heat pump will provide water at 70 degrees to a buffer vessel. In order to ensure efficiency with the CO2 heat pump, it needs a low return temperature. We ensure the low return temperature by controlling stratification in the tank, effectively keeping the bottom of the buffer vessel cool and the top of the buffer vessel hot. On the supply side, the buffer vessel connects to a plate heat exchanger, which heats the mains cold water and the secondary return from the domestic hot water system.